Okay, good morning guys. So I'm going to do and start off with you problems 1 and 3 because problems 2 and 4 are very similar to 1 and 3. So I'm going to do and set you up for number 1 and for number 3. Okay? And so whenever you're doing these conservation of momentum problems, it's best to kind of sketch a drawing because it'll kind of help you see what's going on and just kind of interpret the question as well. Okay, so remember that momentum is just transferred from one object to the other, and it's conserved, which just means that the momentum before the collision, the combined momentum is equal to the combined momentum after the collision. So you'll have before, and then that's equal to after. So basically the momentum of the first plus the momentum of the second before they collide is equal to their combined momentums after the collision. Okay? And then of course remember that momentum is just mass times velocity. So let's kind of sketch a picture. A billiard ball, which is just a pool ball, with a mass of 1.5 kilograms is moving at 25 meters per second. It strikes a second ball with a mass of 2.3 kilograms that is motionless. Find the velocity of the second ball if the first ball stops when it strikes the second ball. So basically, ball A is moving towards a stopped ball B, right? Then they collide. The second ball, find the velocity of the second ball, which means the second ball moves, and then that first ball stops. Okay, so before, after. And then let's start filling it out. So mass, the first ball is 1.5 kilograms, and it's moving at 25 meters per second. So its momentum can be found right here. The second ball's mass is 2.3, but it's motionless. That means its velocity is stopped. The first ball stops. That means its momentum would be 0, but just to be clear, let's go ahead and put its mass times its velocity. It's still going to be 0. And then the second ball, we're looking for its velocity. So remember that momentum is just mass times velocity, and we know that the second ball has a mass of 2.3. And we're looking for that velocity. So that's how you would set it up. And then after that, it's just algebra. Right? So before the collision, the combined momentum is, and I got to get my calculator out too, sorry. 1.5 times 25, 37.5. Okay, so that means that before the collision, the combined momentum was 37.5 kilogram meters per second, and after the collision, it has to be that same number. So what times 2.3 would give you 37.5? You would just divide it out to figure it out. Okay? And that will give you the answer there. So I'll let you go ahead and finish that out. So question number 2 is very similar to that, just with different numbers. So I'll let you work on that independently. Question number 3 is a little bit different. Question number 3 is it's what they call in the lab an explosion, okay? And so I'll start this out with you so that you can try and figure this one out. Okay, so a cannon weighs 2,000 kilograms, and the cannonball weighs 5 kilograms. The cannonball shoots out of the cannon at 500 meters per second. What is the recoil velocity of the cannon? Okay, so what is recoil velocity? Anytime that a cannon or even a shotgun or anything like that is fired, the bullet or the cannonball will go forward, right? Let me just draw real fast. Right, so at first the cannonball is in the cannon, right? And then it fires, meaning that the cannonball shoots out. Well, that's not all that happens, remember, because there's a force that's applied back on the cannon, and so the cannon actually moves back as well. And you're looking for that velocity of the cannon. And this is what they call a recoil velocity. So that's just, it kicks back. That's the kickback that you're looking for. So if the cannonball is in the cannon, then that means that their masses are combined. They start together. So you would actually add their masses. The cannon is 2,000 kilograms, and the cannonball is 5 kilograms. Meaning in the beginning they have a combined mass of 2,005. That's too many zeros. Okay? Now, before the explosion, right, they're not moving at all. So the velocity here is 0. So anytime you have an explosion, before the collision, right, they're not moving, so the total combined momentum is 0. That means that whatever the total momentum is afterwards, it has to equal out to 0. Okay? So they separate. The momentum of the cannon is going to be mass times velocity, and then the plus the momentum of the cannonball, mass times velocity. Whatever it is, it has to equal out to 0, because that's the total momentum before the collision, or before the explosion occurs. Alright, so what are we looking for? The recoil velocity. We're looking for that. The mass of the cannon alone is 2,000 times its velocity. The cannonball has a mass of 5 kilograms, remember, and then it shoots out at 500 meters per second. So we can find its momentum by doing mass times velocity. 500 times 5. Okay? And then you just solve from there. So just be careful when we're asking for recoil velocity, we're asking for this kickback. Take note that it is to the left, which means that this velocity will be negative. When you're done calculating, it'll be negative. All right? So question number 4 is very similar to that. It's a cannon question as well, so you'll calculate it the exact same way.